Awesome. All right, good. So I know we're getting everything ready here. So Sheb, this is actually our first all Texas meetup for the presenter side.
I'm
So
excited. It's been a while. We should have done this earlier.
I know. We should have gotten just Texas meetups for some of these, but now. So how is the weather right now down there? You're in Houston. I'm in College Station. How's it down there?
Yeah, you know how it is. It gets cold, it gets hot. One day it's one way, the next day, who knows? So,
Yeah, I know.
welcome to Texas.
It was cold on Monday, and this morning was like 70 in the morning, and humidity and everything here.
Yep.
Well, very good. So I think we've got. It looks like everybody's joining up now, and let's go ahead and we're going to go ahead and kick off, and let's get the meetup started. Sure. So I'd like to welcome everybody today to our CDP on Azure meetup. This is our third meetup of the year for CDP on Azure, and I'm really excited about today because our topic today is how to harness the power of data flow and event processing in Azure using the Cloudera data platform. So my name is Chris Van Dyke. I'm a principal SE at Cloudera. I'm part of the partner engineering team, and I focus on our integration with the cloud providers, in particular Microsoft and Azure. A little bit about myself. You'll hear from my accent a little bit today. I got a little twang. I'm a longtime Texan, graduate of Texas A&M. I love Dallas Cowboys football, and I'm also a home lab geek, which I'm going to show you a little bit later today. So like I mentioned with the title today, today we're going to be going to talk a lot about streaming in the cloud. In particular, you're going to see how we can scale out NiFi data flows using AKS, and also how we can achieve true real-time streaming and stream analytics, not micro batch. This is real-time streaming using Flink and SQL Streams Builder. And then finally, we've got a great present for you all, especially for y'all that like to tinker around with technology. We've got a present for you at the end of the meetup today, and something you can do over the holidays and tell us back on social media, what you're doing with it. So for everybody, just so you know, we're live streaming this today on LinkedIn, Twitter, and YouTube. And the questions are going to be monitored and answered as we go. So today we really want to get you engaged and chatting with us, being very interactive. So we will be doing a raffle today. As you see on the screen, we've got 2 prize packs that we're going to be giving away. So we've got some great Cloudera swag for you. So everyone who participates in the chat is going to be entered in the drawing. Ask questions early, ask often. We like a lot of activity here. And then we'll do a random drawing kind of game show style at the end, and you must be present to win. So please make sure you stick around to the end. All right. So now to introduce my presenter today. Today we've got Nisheb. Nisheb, go ahead and introduce yourself.
Hi, everyone. Thanks for joining. My name is Sheb. Nisheb, I go by Sheb. I am a senior solutions engineer at Cloudera. I'm also the SME streaming lead, and I'm really excited to be here and share this technology with all of you.
Great. So Sheb, before we get kicked off with everything, kind of why, in this context of big data, what is, I know this is going to be an open question for you, but why is streaming important in a big data sense?
Yeah, I mean, if we really think of, how things have changed over the past decade, in today's world, we now have more devices, more connected devices, more than ever before, all generating data in real time. We have APIs that can access real types of social data in real time, right? We're no longer living in a world where business leaders and enterprises are getting data in batch daily or nightly or weekly or monthly. They're getting data in real time, and with that, they need to be able to process that data in real time and get their analytics back in real time. So the rise of those devices is really what's caused this growing need.
Oh, great. All right, that's a great way to put it, and yeah, I like that. Being able to act on this data faster, act on it when we get the data, not once the data has been brought into a repository and built out into a database. Very good. Absolutely. Okay, cool. Well, I guess it's now all on you. Go ahead and let's take it away with the presentation.
Sure. Oh, actually, I do. Yep. So
All right.
let me know when you guys can see it. We're good.
All right. Okay. So I know we're getting everything kind of up here now.
Yep.
So here we go. Perfect.
All right. All right. All right. So let's get started. Hi everyone. Once again, thanks for joining. Like I said before, my name is Nasha Smiley. I'm a senior solutions engineer at Cloudera. And today we're going to discuss how to harness the power of data flow and event processing using Cloudera's data flow technology. All right, so here's the agenda. Here's what I'm going to walk you through today. I'm going to start by providing a high-level overview of Cloudera Flow Management. So everyone on this call has a general idea of the capabilities of this product. Next, I'm going to go into the data flow lifecycle for CDP Public Cloud. So here I'm going to really talk about the different deployment patterns that are available for Cloudera Data Flow, and then how these patterns or deployments are going to integrate together to give you that full lifecycle set of capabilities. After that, I'm going to cover some of the best practices around flow development. So some of these concepts may be new to even some of the most seasoned data flow developers. So what I'm really trying to do in this section is to ensure that everyone is going to be able to build their flows so they can be operationalized in our Kubernetes-based experience for Cloudera Data Flow. And then finally, we're going to get into a log analytics-based use case. During this time, I'm going to give you a live demonstration of creating data flows using the best practices that I'm going to cover here shortly. And then I'm going to operationalize a flow for you in real time on AKS. And then we're going to run some streaming analytics. So with that, let's get into it. All right, so let's start by covering Cloudera Data Flow at a high level. All right, so Cloudera Data Flow fits into this connected data lifecycle, providing data collection capabilities, right? So think about collecting data from the edge, the data center, or even the cloud, and processing that data and moving it to any type of destination. All of that can be accomplished with Cloudera Data Flow. Right, so the data flow technology is made up of 4 key components. We have edge and flow management. And the key product here is NiFi, which serves as that low-code, no-code solution for data movement. We have stream processing, which enables you to run real-time analytics on streaming data. I'll show you some of this when we get into a live demonstration. There's streams messaging, which provides that buffer zone for real-time data. And of course, we have a syndicated set of services or a shared set of services for deployment management, security, and governance. All right, so going a bit deeper into Cloudera Flow Management, you'll see it provides users with the ability to acquire, process, and deliver any type of data using an intuitive drag and drop interface with built-in processors that can handle any type of data. So NiFi, which is the core component of Cloudera Flow Management, will work with any type of source system, sending data in batch or streaming. It will work with structured, unstructured, and semi-structured data. And with NiFi, you can transform, enrich your data in real time. You can also parse it, route it, and move data between practically any type of infrastructure. And remember, you're doing all this with a drag and drop interface, which I'm about to show you. All right, but before we get into a live demo, I want to cover the data flow lifecycle in CDP Public Cloud. Right, so there are 2 distinct deployment patterns of Cloudera Data Flow, and I'm going to cover them in this section. I'll talk about when to use each deployment, and then keep in mind I'm going to show you both of these in the demonstration. So the first deployment pattern really leverages flow management in a data hub. So here we're going to be running the latest version of NiFi and NiFi registry in a set of VMs. So this deployment is great for flow development purposes because it's automatically going to integrate with Ranger and Atlas and provide you with multi-tenancy and governance capabilities. This deployment pattern is also going to handle all of that, TLS and Kerberos and security-based information and administration for you underneath the covers. So it's really great for developing and testing out a use case very quickly. The second deployment pattern, which everyone's really here for, is going to leverage our Cloudera Data Flow data service. Here, we're going to provide you with the ability to run NiFi on Kubernetes, enabling you to achieve many different things. You'll be able to get flow isolation, so your production flows are no longer competing for resources. You're going to get auto elasticity, which will enable your flows to auto scale up and down based on CPU utilization. You'll get advanced flow monitoring through key performance indicators, all with the centralized flow catalog, enabling you to track and reuse all of your data flows. And I'm going to show you all of this later on today. right? And so these two deployment patterns work together to support the complete data flow lifecycle. So on the one side, we have NiFi and Data Hub, and with this, again, you're going to get a fully secure multi-tenant NiFi cluster that's pre-baked with enterprise-grade security for your flow development. And then with Cloudera Data Flow, Data Service, you're going to get automated flow deployments for CI/CD integration, flow isolation, flow auto-scaling, and advanced flow monitoring through KPIs or key performance indicators. And of course, both of these deployments are going to work together to provide that complete data flow lifecycle. All right, a few more slides before we get into the live demonstration. All right, so at this time, let's get a little bit deeper into flow development. I'm going to cover some best practices that developers should follow when they're developing all of their data flows so they can be operationalized with NiFi and Kubernetes. All right, so the first thing you want to do is uniquely name all of your processors and connections. When you operationalize your flows, you're able to define these key performance indicators or KPIs for advanced monitoring and alerting. And if all of your queues are named success or failure or retry, it's going to be really, really hard to differentiate them. The same goes for processors. Let me give you an example. If you're writing to two different set of Kafka topics and you're using a processor that's named the same, publish Kafka, then it's going to be very hard for you to differentiate them when you define your KPIs. All right, the next thing you want to do is parameterize your connection information. So instead of hard coding things like usernames and passwords and Kafka brokers, you want to create a global set of parameters that can be changed on demand when you operationalize your data flow. Right, this is going to essentially enable you to reuse your flow through the use of the flow catalog without having to redevelop it every time you need to redeploy it. You want to tag sensitive properties as sensitive. This is going to ensure that anything that you type out is not going to show up in plain text, and you'll see that here today. And then you want to define all of your controller services and, in fact, your entire flow that's going to be operationalized inside of a single processor group. All right, so here's an example. Flow, notice the unique names for each of these processors. Right, so this queue follows the best practices because it has a unique name, while this queue is named poorly because you're not going to be able to differentiate it when you define your KPIs. Here's an example of parameterizing your flow. Notice how the Kafka brokers and topic names are not hard-coded. Instead, we're using parameters. This is going to enable you to reuse your data flow, even if your Kafka brokers or your topics change downstream. And then here, you're going to notice that the controller services are all defined on a process group level. And I'm going to reiterate this and show you this on the live demonstration coming up. Right, so there's also a special parameter called CDP environment, right? So during deployment of your data flow, when this parameter is used, it's going to be auto-populated with the environments to do configurations. Think of your core and your HDFS sites. And there's also a default NiFi SSL context, which is going to be pre-configured with your CDP environment certificates. This is going to enable you to communicate with all the data services over TLS automatically. All right, so with that, let's set up the demonstration that I've got for you today. It's going to cover a log analytics-based use case. All right, so I'm going to start by highlighting a log analytics reference architecture. Right, so in this architecture, we can leverage a combination of NiFi, MiniFi, even Kafka clients to collect log data at the edge. And you can think of the edge as any set of servers that's running an application and generating logs. Right, so this data can then be enriched and transformed with NiFi and then pushed downstream to a set of syndicated services that are backed by Kafka. Kafka, of course, is going to be that buffer zone that handles real-time log data, real-time ingest. So downstream, we're going to have any number of applications consume that data from the buffer zone. This is going to include Cloudera Streaming Analytics and SQL Stream Builder, which is going to enable you to write streaming SQL on your data, and I'm going to show you that. The last slide before I get into the demonstration is going to set up the data that I'm going to be using. So I'm going to be using RFC 5424 syslogs that are generated. And here's the metadata that's going to be associated with this log format. What I really want to call out here is the severity field. That's going to define how urgent a message is. You can see on the right side, the severity is going to range from 0 to 7, where 0 is an emergency and 7 means debug. This is going to be really important when we get into our streaming analytics because we're going to stream based on or filter based on this information. So with that, I'm going to now share my screen for the live demonstration. All right, so we're just pulling it up right now. All right, so it looks like everyone can hopefully see my screen. I'm going to be zooming in and out just so to ensure that everyone understands what's going on. All right, so the first thing that you're going to see, the first web UI is going to be for NiFi that's running on a data hub. So this is Cloudera Flow Management running on a data hub. For those of you that haven't seen it before, this is the technology that's going to enable you to do some really complex and sophisticated things around data movement in a much more simpler drag and drop kind of way. So with NiFi, you can simply drag processors onto a canvas, and each processor is going to represent a single action you can perform on your data, whether it's getting it from the source, enriching it, transforming it, encrypting it, writing to a target, and so on. And these processors are also extensible. So what you see on the screen right here is a process group. A process group is essentially a way to compile or collect all of your processors, your use cases into a centralized area. So to create a process group, you simply drag it onto the canvas like this. I've already got one here. I want to show you one interesting thing about it. If I right click it and click on configure, you're going to see that I've assigned a parameter context to this process group, right? This is part of the best practices that I covered earlier. So to create a parameter context, you simply come here, click on create new parameter context, give it a name and hit apply. I've already got one, so we're gonna leave it the way it is and we'll get out of here.
Yeah, you may want to zoom in just a little bit on those as you get
through
them.
Yeah. Yep. So I am now in my flow. You see, I have 3 different processors on this flow that are going to represent my log analytics use case. And remember, this is running on a data hub, so it's a set of VMs. The idea is I want to develop this workflow, this data flow, test it out, and then when I'm really happy with it and ready to operationalize it, then I'm going to move it over to my NiFi and Kubernetes experience or my Cloudera data flow data service. So let's walk through each of these processors. I'm going to first right click on generate syslog and hit configure. So there are many different ways you can get data into NiFi, right? You can have these agents that are running at the edge, collecting information, sending it to NiFi. Cloudera Flow Management or NiFi can reach out to source systems and get that data. It can listen to, for data. For the purpose of today's demo, though, I wanted to do something a little bit more interesting. I'm using the execute script processor here, and I'm going to zoom in. The execute script processor enables me to write custom code in the form of a processor. And I'm able to choose the scripting language of my choice. Here, I have chosen Python. And if I go into what this script body actually looks like, I'm going to expand this out. So all I'm doing is every time this processor runs, it's going to create a brand new flow file. So it's going to create a flow file. That flow file is going to run through this class into this function called process. In this function, I am going to be generating the RFC 5424 syslogs. So if you look at what I'm doing here, if you look at application message ID, structured data, my timestamp, the fully qualified host name, these are all metadata properties that I showed you in the slide. Essentially, I'm just generating them in a Python script, and then I am outputting it right here. So that's the first thing I wanted to show you. Second thing I want to show you was from a scheduling perspective. Notice how I have 4 concurrent tasks here. So when we get into deploying this on our Cloudera Dataflow data service and we want to show auto scaling, it's important to understand that the auto scaling is going to happen when CPU utilization hits a 75% threshold. And so every time this processor runs, I'm telling it to run with 4 concurrent tasks, so I can kind of force that auto scaling to happen. So you guys see something interesting in the demonstration today.
Cool.
Since I'm generating the data itself, I'm also only going to run it on the primary node, so it's going to be running on one of the containers in a scaled out fashion. And then downstream, it's going to be load balanced in a round robin fashion because that's what I have configured here. So I'm generating this data. Let's take a look at what it looks like. You can simply right click, list queue. I'm going to hit the little I button right here. It's going to open up a new browser and a new tab, and you'll see the auto generated data. Right, so we have everything we talked about from the metadata perspective. Look at your version, your timestamp, your fully qualified host name, the application name, and the message, and so on and so on. So a lot of that really unique, data is here. It's being auto-generated. But now let's say I wanted to do something a little bit more complex with it, right? Let's say that structure of the data is just not human readable. I wanted to make it a little bit more pretty. Maybe I want to convert that syslog data into a JSON format. And then after I convert it to a JSON format, maybe I want to run a SQL-based query on it, right? And I can do that using the query record processor. So if I right-click this and click on configure, and I go to properties, you're going to see that I've configured a syslog record reader. So this record reader is going to take each flow file, go through it line by line, read in the data as a syslog, and then write it back out as a JSON. And it's able to do this with the aid of something called schema registry. So I'm hoping you guys can see this. So schema registry, right, is a central repository where you can create these schemas one time and then reuse them across a lot of the components in Cloudera dataflow. So create it one time, use it across many different processors in NiFi. You can use it again in Kafka, and in the near future, you can use it with SQL Stream Builder. It's a Avro-based schema, and you can see all the metadata properties match up with what I had in my PowerPoint earlier. On top of that, I'm going to run a SQL-based query. Notice something very interesting here. Instead of hard coding my SQL query, what I've done here is create a parameter. So this looks very similar to a NiFi expression language, accessing an attribute. Instead of the $sign here, though, we have a pound sign, curly bracket, and the name of my parameter. And in fact, if I go look at what my parameters are, you'll see they pull up right here. So these are all of the parameters that I've defined in my data flow, and these are the values. When I operationalize this in our dataflow data service, I'm going to have the opportunity to update these fields in real time. This is what's going to make your flow reusable, right? You're able to parameterize everything and then deploy that same flow over and over again while changing any of these values on demand.
Very cool.
Right, so I've already ran this one time. I just wanted to show you what that output looks like. So I'm going to go into this queue and hit the little I button. I'm going to format this data, and voila. We're no longer looking at single lines of data. We're looking at JSON files, right? JSON blocks right here. So again, this is going to represent all of the metadata in the RFC 5424 syslogs that I talked about earlier. And since my SQL statement was select star, it's just going to select everything. I'm not really doing any type of filtering. I'll do that later on when I get into SQL Stream Builder. So I wanted to, I can just go back out and run this flow. I'll hit the run button, kind of get everything to run. So everything's running, and then it's going to write to Kafka. Quickly, I'm going to go into this and show you this configuration. Again, instead of hard coding my brokers and my topic and the user I'm going to authenticate as, I've just essentially created parameters. So things are writing to Kafka. We're good. We're happy. But before I operationalize this, I want to ensure the data is actually landing the right way in Kafka. And I can do that by leveraging something called Streams Messaging Manager. So SMM is going to provide you a set of DevOps capabilities around Kafka. It's going to enable you to understand who's producing to what type of or which Kafka topic, who's consuming from those Kafka topics, how much data is coming in, how much data is coming out, what the lag is. You can see a list of all my topics here. And I have my syslog, and I can go into my data explorer, and it's going to provide me detailed information about this topic. So I can see the end-to-end metrics. I can understand how much data is coming in over a period of time, how much data is coming out, how many messages are being queued. I can see the different type of producers that are all writing to this Kafka topic. And if I had a set of consumers, you'll see the consumption and the lag right here. If I wanted to go into my data explorer, I could as well. And this is going to enable me to visually see what is inside my Kafka topics, right? This is really important, really amazing piece of technology. Kafka is no longer a black box. I can actually scroll through the offsets in my Kafka topic, go through my partitions, and again, visually look at my data. And it looks about right. I've got my JSON data that's coming in. The timestamps look about right too, so I'm pretty happy with that.
Good.
So I'll go back out to NiFi and I'll stop this flow. I'm going to go back out to the root canvas. Zoom out just a bit. I'm going to right click it and I'll stop it just to make sure everything gets stopped. And then I'm going to Okay, we're good. All right, so I've developed my flow, I've tested out my flow, I'm happy with it, I've validated everything. Now I want to operationalize this flow. I want to take this and run it on our dataflow data service, which is going to be NiFi on AKS. To do that, I would first right-click on the process group and click on Download Flow Definition. That is going to download this definition in a JSON format. It's going to contain all of my information for all of my flows, all of my connections, all of my names, and all of my parameters. So it's been downloaded, it's right here. The next thing I'm going to do is go into our dataflow data service, and I'm going to operationalize that flow. So this is the dashboard for our dataflow data service. You'll see a list of flows that are currently running. Some are running okay, some have KPI thresholds that have been reached. And I'm going to walk you through some of this in just a bit. Before we even get there, we need to first take that flow I developed and put it into production, operationalize it. To do that, I'm going to leverage the flow catalog. Right, so I click on the catalog button, you'll see a list of flows that I have available to deploy. If I wanted to import a new flow definition, I can simply click on the import button here and then upload my JSON. But since I already have this flow imported, I can search for it, click it. You can see the different versions I have. If I wanted to import a new version, I would simply click Actions, Import New Version, upload my file, add any comments I want, and we're good to go. One of the things I wanted to point out is this CLI command, right? This is really important for CI/CD integration. You can automate this entire flow deployment by using these CLI commands that are built in. So with this command, I can essentially import a new version of my flow. So I already have one of the latest versions in my catalog, and I want to deploy it. So let's try to do that live. I'm going to click on Deploy. And the first thing I'm going to need to do is select the environment I want to deploy it to. I'll go ahead and deploy it to Go 01 in Azure. So it'll take about a few seconds to load. Again, what I'm walking you through right now is how to operationalize that flow. We're going to take that data flow that's been downloaded as a JSON, and we're going to deploy it on a set of containers that are going to spin up, scale out, up and down, and so on.
And that's well, let me, and just so I can add here, and that's one of the cool things about this using the cloud providers managed Kubernetes is we can go and spin these resources up super quick because they've got the, you know, you're not as a consumer of the, you're not paying for the time they keep these things warm for us, these container pods warm. Yep. So it's a great thing, you know, reason why we can spin these things so much faster in the cloud.
Absolutely, absolutely. Thanks for that, Chris. All right, so I've gotten to this page where I'm ready to operationalize my flow. The first thing I need to do is give it a name. So how about live demo? It needs to be a unique name. Then let's move my screen up just a bit. I'll hit next. On this page, I'm going to be able to go in and select the version of NiFi I want to deploy this with. This is really important. You don't have to use a hard-coded version of NiFi. If you want to ensure backward capability, you can do that. You can deploy on older versions of NiFi or even newer ones if you wanted to. We have the option to add custom NARs. So if you're familiar with NiFi, if you're familiar with Cloudera Flow Management, then you know you're able to create custom processors using a bit of Java code and compile them into something called a NAR. And if you have done that and you want to deploy that as part of your Kubernetes-based deployment, all you really need to do is give it a ABFS location of where your NARs are and then access information, user that is able to access it. And once this flow gets deployed, and even when it auto-scales, those NARs will automatically be deployed. You can also determine if I want to automatically start the flow. I'm going to go ahead and unselect that. Click on Next. The next page I get to is going to be a list of parameters, right? So if you remember what I did in my data hub, which I'm going to go back to really quick, and I'm going to right click and go to parameters, and I showed everyone these list of parameters. Instead of hard coding values, I created these global parameters. Well, this is where they show up during deployment, right? And you can see, because I downloaded the JSON file with the pre-built values, they're going to appear here. You don't have to have pre-built values. You can just leave these all empty. I left them in because it's easier for this demonstration, but you're able to go in and add whatever information you want. You're able to go in and change your brokers. You can change your topic. You can change the producer ID, your schema information, right? This is how you're able to reuse this flow over and over and over and over again without having to redevelop it. Here I had a password as a sensitive property. See, you guys can't see my password because this property or parameter was marked sensitive. I'm going to go ahead and click. Yep, right. So again, these are all the parameters. I'm going to go ahead and click next. The next page I get to has to do with sizing and scaling. So I want to determine, okay, what's the initial size of that container that my NiFi is going to run on, my Cloudera Flow Management is going to run on. I'm going to start with extra small. It only has 2 vCPUs. And remember when I showed you my flow, the generate flow file is running 4 concurrent tasks. Well, if that runs 4 concurrent tasks on a small node, a very small node, it's obviously going to need to scale out because 2 cores is not enough to handle it. So we'll start with extra small. I'll decide to enable the auto scaling, and here I can define how many containers I want to scale up to, right? I'll start with 1. I can just leave a default of 3, and this is configurable, and you can go back and change this later on as well, and I'll show you that. Click on next. The next page I get to is for key performance indicators or KPIs. This is what's going to enable you to monitor, alert on things that happen within your flow. And to add a new KPI, you simply come here and click Add New KPI. You get to define what that scope is. It can be on a connection, a processor, a group, system-based information, whatever you want. So for now, I'm going to go into a connection. Connections are queues. When I click on this, you'll see a list of all of these queues names. Now I want to show you guys this. These names are literally what I put in here. So if I had just left everything as a default success or failure or retry, you would have no idea what to do over here, right? So that's why best practice is to name them. So maybe I want to define a KPI on the failure queue. If things are failing, I want to send an alert. I can choose the metric that track. I'll track the flow files queued. And I'll say trigger an alert when there are more than, let's say, 100 flow files for more than, let's just say 1 minute. And I'll hit apply. I want to add a second KPI. Simply come in here, define the scope. I'll click on processor. Here I'm going to click on filter events. The metric I'm going to track is the bytes in. And I'm going to say, hey, send me an alert if there are more than 10 kilobytes for more than 1 minute. Now, since I developed this flow, I know for a fact that there's going to be more than this amount of data coming into this processor. I'm purposely keeping this value low so I can show you what happens when there's an alert. So let's go ahead and hit apply here. I'm going to click on next. Then I'm going to get to this final page where I can review all of my configurations. And it's not just for reviewing. If you look at the top right, you'll see this button called View CLI Command. Everything I just did turns into a CLI command that can be integrated into your CI/CD pipeline, right? So you can automate the deployment and operation of your flows, startup, shutdown, and so on. Again, you'll see information for your parameters, your actual KPIs, and then if you had NAR-based information, that would show up right here. I'll go ahead and hit deploy here. We'll give that a second, and it's going to go ahead and launch. Now, I already have a flow that is running, that's also running on Azure. So I'm going to go ahead and go into that while this starts up. Before I do that, the first thing you'll notice on the flow is there's a little warning that says concerning health. There's an active breach. Let's click on that. If I go into my alerts, you can see, okay, hey, there's a KPI threshold breach happening. The size of the input coming in is greater than 10 kilobytes. Again, I purposely kept that KPI very small. There's also another alert about it's reaching its threshold for auto scaling. I set the auto scaling to 3 and it's already using 2. If I go to my system metrics, I'll be able to see basic information about my flow. So remember, I had very small containers with 2 vCPU. You can see I already have 4 because it auto scaled. I can see CPU utilization down here as well. And I can see basic information on my KPIs. So nothing is coming in that failure to write to Kafka queue, which is good because that means it's not failing to write to Kafka. And for my filter events, I can see I'm getting more than 10 kilobytes in, which is good. It means that my flow is actually running. To go a little bit further, I can simply click on Manage Deployment on the top right. It's going to take me to this page right here where I'm going to get an overview of my deployment on the top. And on the bottom, it's going to enable me to go ahead and redefine or edit or update all of my KPIs in real time or add new KPIs. Same time, I can go in and resize my NiFi deployment and update how it's going to auto scale. I can also update the parameters that I have in real time. If I wanted to update the SQL statement, I could as well. Or if I needed to update my password, I can do that right here. On the top right, the actions, I can actually go in and change my NiFi runtime version if I really wanted to, or I can click on View on NiFi. And if I click on this, this is going to open up NiFi, which is running on AKS. It's running on AKS. Notice it's my flow, the processor group that I showed you earlier. If I double click into it, you'll see it is the exact same flow as earlier. And on top left, you'll see that there are 2 nodes that are connected. I can probably go into, let's go into summary to get some basic information of everything that's happening in my flow, the data that's coming in, the data that's coming out. So we can see that it's running, it's good to go. So here we are, we're running in real time. We've deployed this on 1 container. It saw that there are, the CPU utilization was over 75% and it scaled out to 2. And so now I have this running on 2 containers, auto scaling for you. If I were to stop this flow, it would scale back down to 1. So the next thing I want to show you is streaming SQL. So we've got this flow that's been operationalized, it's scaled out, it's taking all the syslog data and it's writing it into Kafka using containers. Now I want to go and run some analytics on that data in real time. And I want to run those analytics using SQL. I can do that using SQL Stream Builder. So SQL Stream Builder, it sits on top of the Flink engine, which is the gold standard for stream processing in real time. And with SQL Stream Builder, you guessed it, I can use SQL to create real-time applications that query my data. So if I click on the results tab, you'll see an example of some of the data that's going to come out when I run this. And I'm actually going to run this for you live. This is from a previous run, but I'm going to run this for you live right now. I just wanted to show you what some of that data is going to look like. It's going to essentially take all of that data that's in Kafka and it's going to apply this filter to it, which is where severity is less than or equal to 3. And that's the only data that I'm going to see here. Before I run this, I want to also talk about what you can do with this data. So it's not only going to just appear on the screen, you can take the results of your SQL statement and push them downstream into like another Kafka topic, or you can connect them into a webhook, or you can even generate something called a materialized view. So a materialized view is like a point in time snapshot of your real-time data. This is really useful if you're doing things like machine learning on real-time data. When you're doing ML, you want to have an API to be able to reach out and collect a snapshot of that data in real time. And you can do that through a materialized view. And to create a materialized view, it's actually really simple. And I'm going to do that right after, I'm going to stop this. I'm going to do that right after I get this running for you in real time. I'm going to hit execute right here. So you can see the statement is select star from syslog, right? So syslog represents a virtual Kafka table. So how do I create these virtual Kafka tables? I'll show you that in 1 second, but as you guys can see right now, I've already started this flow and data is coming in real time. Severity is all less than 3. So to create this virtual table, I'm going to simply click on this tables tab. All I have to do is click on add table, click on your source. Here it's going to be a Kafka table. I get to select my endpoints. So here I've already connected into my Kafka that's running CDP. You can also connect this into any other Kafka as well. Under topic name, you're able to go in and take a look at all of the topics that I have. Here, I'm going to be using my syslog topic. I need to give the table a name, syslog live. And then I need to define the schema for that table. So you can get the schema using schema registry, or you can click on the detect schema button. With detect schema, what it's going to do is going to go out and sample your Kafka data. And using that sample, it's going to go and try to auto-generate an Avro-based schema for you. And you can see it just did that for you in real time, right? So I didn't really have to type it out. It did it for me. With Kafka, you can also define, with SQL Stream Builder, you also need to have a timestamp field within your data. You can either use built-in Kafka timestamps, or in the case that you have a timestamp field, you can use that as well. If you wanted to transform your data in real time, you're able to do that as well. You can use simple JavaScript to read in your record, transform it, and then write it back out. It's a really neat feature right here. So I'm going to go ahead and close. If I go into this, you'll see that I already have an existing table. It's called syslog. It's going to be a virtual table that's going to be sitting on top of my Kafka. And here on the right-hand side, you'll see the DDL for it. Once again, I go back to the compose, and you can see that this application is running in real time. And I'm getting all of my data that's being pushed out in real time. And then the last thing I want to show you was materialized view. So I can simply copy my materialized view URL, post it, and voila. With that, it's web hosted in absolutely no time at all. And just to show you real quick how to create a materialized view, I'm going to click stop right here. I'll go to materialized view. We'll give this a second to auto refresh. There we go. And it's no longer running. So I'll give this a second. I'm going to go between my data providers, my console. Click on materialized view. I simply click on enable on the top right. And then I'm able to define whether or not I want to delete that data in real time. And then I'm also able to add a query, and that query can match what you have on your SQL site as well. So that's all I have for you. We're going to turn it over to questions at this time.
Very cool. That was a great demo. I like the way you walked through it, and kind of an end-to-end example of data coming in, data going through a flow, scaling it out, and then bringing it into run analytics on top of it. So, and for everybody out there, we are taking questions. Make sure you put them into LinkedIn or YouTube comments, wherever. Put them in there, and we'll, and I can ask them of Sheb. So, okay, first question from one of my favorites out there. He's been to all 3 of our meetups, MC Cat. Can I register a custom processor inside of a CDP flow with NiFi? I think he's thinking go ahead.
Yeah. So there, you can actually hot load them into NiFi, right? So you no longer have to log in and go straight to the lib directory and copy over your NAR. There's a procedure we have well documented that enables you to hot load them from an ABFS location, or depending on your cloud provider, their object store location.
Very cool. Okay. And then from Ali Bajwa, he's asking, what are some other use cases that benefit from the power of data in motion?
Yeah, I mean, the use cases are endless. Today, I showed you a log-based use case, but let's expand that into other, enterprises and industries. Think about cyber, right? You can be pulling in DNS-based logs, PCAPs, doing capture, deep capture analysis. Think about predictive maintenance. Think about financial transactions. Anything that has a streaming use case across any industry can be leveraged there.
Exactly, and predictive maintenance is a great one, because if you think about when I need to get to a point in equipment reliability, when I need to get to a point where I can detect a problem and make action on it at the time the data gets generated, not when I run some analysis in a database. I mean, that's where it gets really powerful, is I can see that some bearing temperatures are running really hot and there's a lot of vibration on a motor. I can immediately alert somebody to go check out that compressor before that compressor fails. And so you can get that working quicker than letting it fail and you loss of production. So that's a great use case there.
Absolutely.
Okay, so next question from Harshit. He's asking, do we have a connector for Flink also within NiFi?
Yeah, I mean, there's a lot of community work being done around that area. So for sure, there are different connectors that you can use to do that. Typically, in streaming reference architectures, though, we use Kafka as like glue, kind of like that architecture diagram I showed you earlier in my deck, right? You want to take your data, load it into this buffer zone where you can replay that data from multiple different type of consumers, and one of those consumers can be Flink. It doesn't have to be the only one as well.
Right. Very good. Okay, next question from. And I apologize on the name here, Adish Shankar, is the CDF UI, is CDF part of the on-prem install of CDP?
Yeah, so Cloudera dataflow, Cloudera flow management, which is built around NiFi, is available both on-premise and in the cloud today. Our dataflow data experience, which is going to enable you to run NiFi and Kubernetes, is available in the public cloud, and then next year it'll be available on-prem as well.
Okay. Very cool. And actually, somebody, because they know we're from Texas, somebody just asked, can NiFi help the Houston Texans?
Oh my
And
God.
being a Cowboys fan, I'm gonna tell you, no, it can't. There's no chance for Texans, but watch the Cowboys.
No, I don't think you want to hear my true feelings on that one, so I'm going to pass
All
on the
right,
question.
very good. Okay, hey, another question here: is the threshold for auto scaling, is it preset at 75%, or can we modify that?
Yeah, so it uses HPA underneath the covers, and by default, that defaults to 75%, but it's a configuration in the YAML file that can be updated. So yeah, I mean, if you really wanted to change that to something else, definitely it's something we can do.
Very good. All right. Well, hey, that's great. I think we've hit most of the big questions here. And now we can kind of jump to the next part. And so the next part is yeah, my little presentation here, my demo. And what we wanted to do is go into the holiday season. We wanted to kind of have a gift for everybody and something that you could take over the holidays and do a little learning with. So about a month and a half ago at Flink Forward, we debuted in Cloudera Streaming Analytics Community Edition. And you can go to our web, and I'm going to kind of take you through what you got to do to install that. This is an installable tool you can put on your laptop, your PC, a VM somewhere, where you could actually that SQL Streams Builder and Flink and Kafka bit that Sheb showed, you can actually run that on your own machine. So if you go, and we'll have a link later in the presentation for it, but if you go to the cloudera.com and you'll find a link for this. And all you've got to do is you'll hit let's go and accept the terms. And we've got, and this is how easy it is to install this. All you've got to do is download this Docker Compose file, and you'll put the Docker Compose on your machine. And so I can see I'm here on my Mac right now. I'm in a directory. I've already pulled down that Docker Compose file. And so let me show you what that looks like real quick. Oh, it's a normal, if you've used Docker Compose before. So you're going to install Docker and you're going to install Docker Compose. And this is just a normal Docker Compose file. And what we'll do is I'll go Docker Compose up. And behind the scenes, Docker is pulling in a container for Flink, a container for Zookeeper, a container for Kafka, and SSB. It's setting up all the networking and all that. And the first time you do this, mine's going to go a little faster here today. It'll be about 30 seconds till it all comes up. The first time you run this at home, though, you have to build out the container, so it may take a couple minutes, 5 or 6 minutes for this to get done the first time you do it. I've done it before, so right now it's just spinning up the containers that are already on my machine. So we should start seeing the log in just a minute here. And yeah, I really hope I hope you take a chance, go and install this. It's a great thing to be able to play with, and I'll show you in just a second as soon as this starts. And here we go. We see the logs have come up. My console's come up. Everything is starting to run on here. So I'm going to flip back. And as part of the package here, we in our documentation, we're also giving you a quick start guide. So this quick start guide kind of walks you through running, building your first table and all that. Once all the Docker Composes come up, you're going to go, you'll go to localhost 8000, port 8000. So this is running it off my machine, and it's admin for the username and password to log in. And so I've got it up and running, and I've already gone through the quick start on here. So I'm just going to quickly show you. So what we do as part of this, we're going and we'll create a table called orders, and behind it we've got a generator that's behind there. It's generating data. So I'm able to, and this is, this isn't really a stripped down application. This is our SQL Streams builder sitting on top of a full-fledged Flink install. So I can go select star from orders, and I'm going to execute that. And so it's spinning that Flink job up, and it'll start streaming out, and you'll see some data start coming in. And so see, I can see data that's now coming in, and that's really cool. So, but this is data that's being generated by this little Faker application on here. But what I want to show you is something even cooler you can do with this. So it's not just, you don't just have to run the Community Edition on your laptop. You can actually run this against real Kafka data. Say you've got Kafka data that's in your home lab. So what I'm going to show you is this is actually something I kind of geeked out over the weekend, and my house is pretty instrumented out to where I'm pulling a lot of real-time data in. I'm bringing that through Kafka and doing stuff with it. What I'm showing you now downstairs in my garage, I've got a Sense smart meter that's sitting on top of my fuse panel here at the house. And that smart meter, or that Sense meter, is actually watching real-time consumption coming in the house. So you're seeing currently how much electrical consumption I have in my house. I'm grabbing this data and I'm dropping this into Kafka, and I've actually set up SQL Streams Builder out on one of my servers here at the house. So I've got a little virtual machine that's running this, and I've already gone and created a table that's looking at that Kafka topic in the house, and it's bringing in those tags and readings from that topic. So I'm going to go run this. And so it's starting the job up. I should say one of the limitations, though, of SQL Streams Builder and Flink as part of the Community Edition is you can only run 3 SQL jobs at one time. So now you can see it. I've got, and I'll make that just a little bit bigger for everybody. Yeah, you can see that data is now flowing in, and every couple seconds, I've got my total energy consumption by watts right now coming in. So I hope you all take the time to go and download this, the Docker Compose, run it on your machine, and get a little experience with this. So let's see if we have any more questions. I'll jump back over to questions. And let's see. So I've got somebody asking for the link. So we'll actually show you, Joan. We have a link coming up a little later. We'll have that for the Community Edition. It'll be out there for you in just a few minutes. Also, for Sheb, how scalable is CFM?
Yeah, I mean, it's really scalable, right? When we talk about CFM, we need to first go back and really consider what I talked about earlier. There's 2 different deployment patterns. There's CFM that can run on a set of VMs, or even on bare metal if you're on-prem, and there's CFM on Kubernetes. So both are extremely scalable. That being said, you have to understand, the underlying architecture of NiFi calls for a smaller number of dense nodes. It's kind of like the opposite of the Hadoop-based ecosystem, right? So typically you can start with about 3, and then you can scale out. Going over 10, you got to have some really massive throughput to even consider that. But if you needed to, it can definitely do that.
Very good. Okay. And I think I got one more question maybe popping up, and let me see if this comes up. But I guess you're still typing, so I'll go ahead and ask. So Sheb, as we're wrapping up kind of your portion of the day, great demo. I really loved what you showed today. I guess kind of go ahead and you can kind of wrap up and give kind of the call to action for the Data in Motion, the Data in Motion team, looking at our streaming products.
Yeah, absolutely. Well, first of all, thank you for demonstrating the community edition of CSA, right? So that's available for everyone to go out and download. And then also, if you're interested in trying out the NiFi and Kubernetes-based data service in Cloudera, please feel free to sign up for the 60-day trial. And that's going to be part of the links that's going to be passed out to you. You can sign up, you can get it deployed, you can start playing around with both data hubs and NiFi and Kubernetes and do some amazing things.
Very good. All right. Well, hey, thanks a lot, Sheb. Thanks for coming on today and giving your time to do the presentation. So that's all
Thank
the
you.
questions we have, and we'll kind of move on from here now. All right. So see you, Sheb. Okay, now next, from a resources standpoint, here's some links for you. We've got a link for the Cloudera Stream Analytics Community Edition. And then there's a couple of links there for, how to get onto a CDP trial, and some of those, some of the other things out there. And then for our future of data meetups page. So, so for some of the participants out there, you may receive a survey. And we'd love it. And we always like feedback on these. The content, we're always working to strive to put better content out there and give you, great conversations when we bring this out. So please, if you get the survey, fill it out, send it in, and we'd love to have your feedback. So, all right, now I know it's we're to that point of the day where we're going to do the raffle, and let me pull the names in for the raffle today. Just a second here. There we go. Oh, wait. Just a second. It takes me a minute to cut and paste these in. All right. And go ahead and you can switch over for me, and we'll start the spinner. So we've got those 2 prize packs that we showed earlier. And let me go ahead and spin and see who our first winner is going to be. And the first winner is, all right, come 3 times, you're going to get a prize. MC Cat, congratulations. Thanks for coming and thanks for being a part of this. And then let's go one more time. And our winner number 2 is Tarun Dave. And I'll tell you what, since it's Christmas time, or since it's the holiday season, we're going to go ahead and spin this one more time. And we're going to give 1 extra prize pack this time. And the next prize will be Henry Sowell. All right, thank you, everybody. For all those that won today, we'd like you to email your contact information to socialmedia@cloudera.com so you can claim your prize. And this concludes our meetup today. So on behalf of the whole team here, I'd like to thank everybody for coming out and helping make such a great event this evening. I'd really like to thank all the questions that we had. Questions are always what makes these, these meetups better, is when we get that interactivity and we hear from y'all. And we really look forward to seeing you at the next Future of Data meetup. Please feel free to, I really like we're looking at our next topics for next year. So for everybody out there, if you have something you want to see around the big data, machine learning, data in motion space, streaming, any of that, please feel free to look me up on LinkedIn and hit me up with anything or email us with any topics you'd like to hear from us. We really look forward to seeing all of you at our next Future Data meetup in 2022. So thanks again for joining us, and bye. Have a good one. Have a great holiday season. Thank you.